Hello students, today we will discuss the topic compressor. So first of all, let us know what is a compressor. So compressor is a device which will raise the pressure of the fluid by compressing it, and then it will deliver it to the required storage tank. So the objective of an air compressor is to raise the pressure of the air with minimum expenditure of energy. So here we are discussing mainly the air compressor. So the objective of an air compressor is to raise the pressure of air with minimum expenditure. Then reciprocating compressors are used in chemical industries, fertilizer plants, refrigeration industries, and metallurgical industries. And they are also used to compress air, gas, or vapor. So reciprocating compressors are used in chemical industries, then they are used in fertilizer plants, they are used in refrigeration industry, they are used in metallurgical industries, and they are used to compress air, gas, or vapor. Okay. So what does the compressor do? So here reciprocating compressors are used in many applications like chemical industries, then fertilizer, then refrigeration industry, and metallurgical industries also. They are used mainly to compress the air, that is to increase the pressure of air, gas, or vapor. So how does the compressor actually work? So an air compressor sucks air from the atmosphere, then it will compress it, that is it will increase the pressure and it delivers it to the storage tank, delivers the same, that is the compressed air to the storage tank. So from the storage tank it is conveyed by pipelines to the application region. So from the storage tank it will deliver the compressed air through pipelines to the application region. So like the pumps, even the compressor has to be driven by a prime mover. Okay, so it cannot run by itself. Okay, it will require a prime mover, usually a diesel engine or electric motor, because compression of air requires some work to be done on the air. So compressor has to be driven by a prime mover which can be diesel engine or it can be electric motor. Okay, as compression of air requires some work to be done on it. Now we will see how does a single stage reciprocating air compressor works. So working of a single stage reciprocating air compressor. So a reciprocating air compressor consists of a cylinder. So this is a single stage compressor. Okay, this is a single stage reciprocating air compressor. So it consists of a cylinder which you can see here. Okay, this casing is a cylinder. So components of single stage reciprocating air compressor. So it consists of cylinder. Okay, then there is a piston. Okay, so you can see this is the piston here which is mentioned here. Okay, then there is a crankshaft. So this is the crank or crankshaft. Okay, then there is a connecting rod. So here this is the connecting rod which is mentioned here. Then there is inlet and outlet valve. Inlet valve and outlet valve. So you can see there is an inlet valve here. Okay, and delivery valve is nothing but the outlet valve. So this portion in black color are the valves, which is inlet here and the outlet valve is above. Okay, so during the downward motion of the piston, so here you can see the piston is, so if this is the cylinder, okay, the piston is in the downward position. So during the downward movement of the piston, the pressure inside the cylinder falls below the atmospheric pressure. So the pressure inside this cylinder. So when the piston moves here, there is some empty space here. So what happens? The pressure inside the cylinder will fall below the atmospheric pressure. So it will become less than the atmospheric pressure. And the spring loaded inlet valve is opened due to pressure difference. So because of in a decrease in pressure, this inlet valve which is spring loaded will be opened. The pressure, so when the pressure inside the cylinder will fall below atmospheric pressure, and the spring-loaded inlet valve will get opened due to pressure difference. Then what happens when the inlet valve is open? The air will be drawn into the cylinder until the piston reaches the bottom dead center position. So air will be entering into the inlet valve through the inlet valve into the cylinder until the piston reaches the bottom dead center position, until the last position. So when it is coming downwards, there will be flow of air inside the cylinder until it reaches the bottommost position. So the air is drawn into the cylinder until the piston reaches bottom dead center position. Okay. So what happens when the piston moves down? There will be fall of pressure inside the cylinder, and that is why the inlet valve will get opened and the air will start flowing inside the cylinder. Then as the piston starts moving upward, the inlet valve will get closed and the pressure starts continuously increasing until the pressure inside the cylinder is above the pressure of the delivery side, which is connected to the receiver. So as the piston starts moving upward, so when the piston moves in the upward direction, then what happens? The inlet valve will get closed. The inlet valve is closed and the pressure starts increasing continuously until, so the pressure here, the pressure of the air inside the cylinder will start increasing continuously until the pressure inside the cylinder, that is the pressure of the air, the cylinder is above the pressure of the delivery side. So this is the delivery valve here. The portion in black color is the delivery valve. So the pressure will increase up to a point which is more than that of the pressure on the delivery side, which is connected to the receiver, which is connected to the receiver. Then what happens? Because of increase in pressure, the delivery valve opens and the air is delivered to the receiver during the remaining upward movement of the piston. So then the delivery valve opens and air is delivered to the receiver during the remaining upward motion of the piston of the piston. So at the end of the delivery stroke, a small amount of high pressure air is left in the clearance space. So here you can see there is a clearance space. So the line, the portion above the dotted line. So this is the dotted line. The portion above the dotted line is the clearance space. So at the end of the delivery stroke, that is after the full air is gone to the receiver from the delivery valve, there will be some portion of high pressure air which is left inside the clearance space. So at the end of the delivery stroke, a small amount of or small volume of high pressure air is left in the clearance space. So the high pressure air which is left in the clearance will expand as the piston starts moving downward. The high pressure air in the clearance expands as the piston moves downwards. And the pressure of the air falls until it is less than the atmospheric pressure. The pressure of the air falls until it is less than atmospheric pressure. So the inlet valve will again open as the pressure inside the cylinder falls below the atmospheric pressure and the air from the atmosphere is taken inside. Okay, that is the suction occurs. So this cycle will continue. Okay, this will keep on repeating. So the inlet valve then opens as the pressure inside the cylinder falls below atmospheric pressure inside the cylinder. Sorry, pressure inside the cylinder falls below atmospheric pressure and the air from atmosphere is taken in and the cycle is repeated. So the suction, compression and delivery of the air takes place within 2 strokes of the piston or 1 revolution of the crank. So here you can see the cranks keep on revolving and the piston keeps moving upward and downward. So the suction, compression and delivery of air takes place within 2 strokes of the piston or 1 revolution of the crank. Suction takes place during 1 stroke and compression takes place during the 2nd stroke. Suction takes place during the movement of the piston downwards. When the piston moves upward, then compression takes place. So suction. So within 2 strokes, the cycle completes. Takes place during 1 stroke, that is the downward movement of the piston, and compression takes place during the 2nd stroke, that is during the upward motion. Compression and delivery takes place during the 2nd stroke. So these compressors have many applications. So this is how we have seen the working of the air compressors. Now we will see the applications of the air compressor. The first one is the refrigerator. Okay. So in all the cases, the same process is taking place. So what happens? So this is the compressor in the refrigerator unit. So what it actually does is, so the refrigerant will get inside the compressor. This will increase the pressure of the refrigerant. Okay, how does it increase the pressure? We have seen, that is the piston which is present in the compressor will move downward. Okay, and there will be pressure drop inside the cylinder, because of which the air or the refrigerant will get inside the compressor. Okay, and then when the piston moves upward, then the pressure inside will increase and this will be delivered to the receiver end. Okay, here the receiver end is the condenser. So what the compressor is doing, it is converting the refrigerant, okay, of low pressure into very high pressure. Then it is sent to the condenser where it will convert the high pressure refrigerant into liquid droplets. Okay, it will condense it and convert it into droplets. Then it is sent to the evaporator where it will get, where the liquid will receive all the heat and it will evaporate. Then with the, it will become of very low pressure. Again it is sent into the compressor to increase the pressure. So this is how the compressor is working. So that is the work of the compressor in a refrigerator. The same way it is working in a water cooler. So again here refrigerants are used. Then split AC unit. So here we have taken example of refrigerator unit and split AC unit. So here also you can see there is a compressor, condenser, okay, evaporator, blower, okay, which is blowing the air. Then there is a capillary tube also. So for the condenser there is a motor attached, okay, there is a fan. Okay, so the same way how we have seen the working of the compressor in the refrigerator unit, the same way even here the compressor is increasing the pressure of the refrigerant fluid and then sending it to the condenser, which will then send it to the evaporator. Okay, and the cycle continues. Then oxygen or nitrogen plants, generation plants. Okay, then it is used in laboratories and in research facilities and in pharmaceutical industries. It is used in food processing industries and packaging unit industries. It is used in electronic productions, then in oxygen generation plants, ozone generation plants. Then it is used in printing equipments, then in fermenters, and in applications that are zero tolerant to oils in compressed air. So applications that are zero tolerant to compressed air. Then in air blowguns to clean machinery. So these are few applications of the compressor. So this completes the topic compressor. I hope you have understood the topic. Thank you.